Okay, so let's find the derivative using what we call the limit definition of the derivative. So first thing we need to do is find out what f of x plus h is. So that will be x plus h squared, and that's x plus h times x plus h. And that is x squared plus 2xh plus h squared. You're going to find that this shows up often, so you're going to want to memorize that. So now let's substitute into the limit definition of the derivative the f of x plus h, which is these three terms, f of x, which is just this term. So here we go. The limit as h approaches 0 of f of x plus h, which are these three terms, so we get x squared plus 2xh plus h squared, minus all of f of x, which is just one term, so you don't have to worry about distributing the minus sign, all over h. The next step is to clean up that numerator, anything that can be added or subtracted. So notice that you have x squared minus x squared, so you're left with the limit as h approaches 0 of 2xh plus h squared all over h. And then you're going to let you need to factor out an h. So notice that h is common to all the terms. So we get the limit as h approaches 0. And if I divide h into the first term, I get 2x. If I divide h into the second term, I'm left with just h. And so then I'm now going to let h go to 0. So f prime of x is equal to 2x plus 0. So f prime of x is equal to just 2x. And that is your answer. Realize a few things that happened here. First thing that we should do is find f of x plus h. Second thing you do is substitute all the terms into the formula. Then anything that does not have an h should cancel out. Then you're going to factor out an h. And then you're going to let the h go to 0 right here. And then that would be the way you'd use the limit definition of the derivative.